Problem 109 has us looking at fireworks. We are given an equation, and with the equation, h is the height after t seconds. So when we take a look at this very first problem, problem A, what is the height of the platform? Well, that's going to be when t equals 0. So when time equals 0, it's going to be when they are first lit off. So that means the height is going to be a negative 4.9 times 0 squared plus 49 times 0 plus 11.27. So our height, all these become zeros, so our height is 11.27 meters. So then the maximum height, so if we think of a quick picture of this, so it's already starting off 11.27 meters above the ground. The fireworks are launching from there and coming down. So the maximum height is going to be the vertex of this parabola. So there's a couple things I could do. I could complete the square with that equation and find my vertex that way. I also need to figure out how many seconds till it hits the ground, so I could solve that with the quadratic formula, and that would give me the answer over here, and it would also give me another answer over here, which is negative time, because it would be just where the parabola is intersecting the x-axis. But that would also then help me establish my line of symmetry as well. So I'm going to go through and do the quadratic formula for this problem. So I'm going to have solving for t. I'm going to have the opposite of b plus or minus the square root of 49 squared minus 4 times my a value times my c value, all divided by 2 times my a value. So simplifying this here, I get underneath the radical, so all of this underneath here, that is called the discriminant. So the discriminant for this problem is 2621.892, all divided by negative 9.8. So again, simplifying, I take the square root. I get about 51.0204. all over negative 9.8. That gives me, again, two solutions. One of them is 10.225 seconds, and the other one is negative 0.225 seconds. So how many seconds before it reaches the ground is going to be 10.225 seconds approximately. This other one does not make sense for the problem because that is, again, negative time. So, however, I am going to use both of these equations right now to help me find my vertex. Another thing I can do to figure, so if I would average these out, I will get my line of symmetry. But another thing I can do is anytime you're doing the quadratic formula and you're averaging the quadratic formula out, these also just cancel out. So the line of symmetry is always the opposite of b over 2a. So if I look at that, my line of symmetry is going to be the opposite of b divided by 2 times my a value. So when I calculate that, I'm going to end up getting 5. So that is when t equals 5. So after 5 seconds, I'm going to have my line of symmetry, and I'm going to have the highest point of that parabola. So now I'm going to evaluate by putting 5 in here and putting 5 in right there and finding the height. That height ends up being about 133.77 meters. All right, the next part here. is if I wanted to go through and rewrite the equation in factored form. So if I wanted to look at that, I already know my x-intercepts. My x-intercepts were 10.225 and negative 0.225. I know that my stretch factor, or my a value, is a negative 4.9. So if I just wanted to write this in, forcing this into a factored form, it'd be negative 4.9 as my stretch factor, x minus 10.225, and x plus 0.225. I would get this root from that factor and this root from that factor. And that factored form, how might it help here, as this question is asking? Well, it's going to help me by giving me the roots, or basically my x-intercepts. And now we're done with the problem.